in this video we're going to be doing Calc AB Problem Set 94. The problems and a playlist are in the description below. Let's look at the problems. Number one, a particle starts at 10, 0, so it's on the x-axis, I guess, at time t equals 0, moves along the x-axis, such that its velocity for t greater than 0 is given by v of t equals 2t over 1 plus 16t squared. This particular question is based on a question that was on the 1971 AP Calculus exam, so it was number 6, but this is only based on it, it's not the actual question. All right, we want to find the maximum volume attained by the particle. So volume, velocity, I don't know why it says volume, maximum velocity attained by the particle. We're doing velocity. All right, so we are given velocity, we want the maximum velocity, we need v prime, so let's start with that. So it's going to be the quotient rule, so bottom, derivative of the top is 2, minus top, which is 2t, derivative of the bottom is 32t, all over the bottom squared, so make sure you use parentheses there. And then, we need to set this equal to 0 because we're looking for the critical points, so I'm going to simplify it a little bit. You take out a 2, you get negative 16t squared plus 1, and then you have your denominator of 1 plus 16t squared. All right, so the denominator is just going to cross multiply to 0, so that's out. So v prime of t equals 0 is going to mean that that numerator is equal to 0, which means either t squared, well, t squared should be 1 over 16, so t is either plus or minus 1/4, but t is greater than 0, so t would have to be positive 1/4. So now we have to figure out if this is a maximum or not. If it's not a maximum, then we would need to look at like what's happening at 0 and also what's happening as we go to infinity, I guess. So hopefully this is a relative maximum. So sign chart 1/4. This is a sign chart for v prime. I'm going to take a number that's really close to 0 and sub it in. So I'm going to sub in like 1 over 100. So I'm just indicating that's what I'm doing. 1 over 100, you square it. 16 divided by that is basically 0. So we're getting just a positive. We're getting like 2 over some positive number. So positives here, and then if you plug in a billion, there's like no upper bound here. That's definitely going to give you a negative. So let's see if we can write this up. So I'm going to say on t greater than 0, there's only one critical point. So that's an important fact here because we're looking for the absolute maximum. So we need to establish that there's like one critical point or test endpoints and things. So one critical point, v prime changes from positive to negative, so v definitely has a relative maximum there, but we're looking for absolute. So combine those two ideas. There's one critical point, it's a relative maximum, it's got to be the absolute maximum. So that's what I'm going to write down. So since v of t has a relative maximum at the only critical point, v of t has an absolute maximum there. That's the only option for where you could have the absolute max in this case. All right, and then we need to actually find the velocity, so we're going to plug in 1/4. Turns out when you plug in 1/4 to v, you get 2 times 1/4 is 1/2 divided by 1 plus 1 divided by 2. So 1/2 divided by 2, 1/4. All right, that's part A. Let's look at part B. Find the position of the particle at t equals 2. All right, so I'm thinking of this in terms of where I'm starting plus displacement. So to do this problem, we know that we're looking for x of 2. We are told in the problem that you start at 10, 0. So x of 0 is 10. So we're going to do 10 plus the displacement. The displacement would be the integral from 0 to 2 of the velocity. So v of t. Now we have to actually like integrate this thing. So that's going to be, I'm going to rewrite it a little bit. I'm going to do 10 plus. Okay, so it's going to be the integral from 0 to 2 again. I've taken out the 2. So 2 times the integral from 0 to 2, t over 1 plus 16t squared. So by the chain rule, there should be a 32 in the numerator there. So what I'm going to do is a 32 in the numerator, 1 over 32 outside, and now I can perfectly integrate 32t over 1 plus 16t squared just by u-substitution. It's a natural log. You can do the work if you want to, but you can also just think it through. So here we're going to have 10 plus 1 over 16, natural log, absolute value, 1 plus 16t squared from 0 to 2. I'm going to plug in and get 10 plus 1 over 16. You get the natural log of 65 minus the natural log of 1. Natural log of 1 is 0. So ultimately we get 10 plus 1 over 16, natural log of 65. It's not like a nice looking answer, but it is the answer, and that's okay. All right, let's look at part C. Does the particle ever pass through the point 1000, 0? We want to justify. So I can think of two ways to do this. One of them is, instead of what we did last time where we found x of 2, we could just set up the integral again, but set it equal to 1000. So that's what I'm going to do. I'm going to do 10 plus the displacement. So starting at t equals 0, I get 10. The displacement between 0 and whatever t is going to be the integral from 0 to t of the velocity. I have to use a dummy variable, so I'm going to use u. So 2u, 1 plus 16u squared du. This should equal 1000, or we're going to see if it equals 1000. If it does, then the answer is yes, you do get to that point. If it never equals 1000, the answer is no, you do not get to that point. So subtract 10 from both sides. We already integrated this, right? So it's like you can take out the 2, and then you would need like a 32 and a 1 over 32. So you end up with 1 over 16, the natural log of the absolute value of 1 plus 16u squared from 0 to t, and that equals 990. If you don't like doing these things in your head, just like write them down. There's nothing wrong with it. I just typically will skip that step. Now I'm going to use the fundamental theorem. It looks a little weird because the first part just gives us a t, right? Natural log of 1 plus 16t squared. And then when we plug in 0, we get the natural log of 1. We know the natural log of 1 is 0, so that's doing nothing for us. I'm going to multiply both sides by 16 and clean up that natural log of 1 situation. Gives me natural log of 1 plus 16t squared equals 16 times 990. I did this on the side, so I got that I'm exponentiating and I multiplied 16 times 990. So I get 1 plus 16t squared is e to the 15,840. I don't know. We're going to subtract 1, divide by 16. That gets us t squared is 1/16 of e to the 15,840 minus 1. Then square root, we want the positive square root because t is greater than 0. So this would be the t value when you get to 1,000. So the answer is yes. I actually can think of another way to do this where I'll go through it a little quickly. You can actually solve for x of t as we kind of did in the previous part, I think in part B. And once you have that, you can see that the limit as you go to infinity would equal infinity. Now, position is definitely a continuous function, and we know that x of 0 is 10, which is less than 1,000, which is less than infinity, clearly. So by the intermediate value theorem, x of t must equal 1,000 for some t. That might actually be an easier explanation if you prefer that. Whatever you go with, doesn't matter to me. Both of them I think are equally good. So the first one that I did is really dependent on you being able to solve that equation, which there's almost no guarantee that you could. In this case, you could, maybe not. The second argument is like rock solid, and you don't have to find the value, so I kind of like it more. All right, next up. Evaluate the integral from 2 to 6 of the quantity x minus 4 to the 4th minus 1 over 1 minus 3x dx. All right, so first time I did this problem, I had like so many mistakes. I don't know, I just completely messed it up. But we're going to reverse I'm just diving in here, right? So x minus 4 to the 4th, the chain rule would give us a 1, so we're good to go. I'm going to do plus 1 times the reciprocal, so 1/5, quantity x minus 4 to the 5th. Now we need to integrate, so there's a minus sign. We need to integrate 1 over 1 minus 3x. So the chain rule should have given us a negative 3 in the numerator. So negative 3 in the numerator means a negative 1/3 on the outside. So we get minus negative 1/3. And then all of that work was to make this thing the natural log of u, basically, right? Where u is 1 minus 3x. So natural log, absolute value 1 minus 3x. We're going from 2 to 6. All right. So first I'm going to plug into this like thing to the 5th. I'll have 1/5. Plugging in 6 gives me 6 minus 4 is 2, so 2 to the 5th. Minus plugging in 2 gives me negative 2 to the 5th. So look at that. That's 2 to the 5th minus negative 2 to the 5th. Negative 2 to the 5th is negative 32, so it's 32 minus negative 32. That's going to be 64. Keep that in mind. When we just plug in here, so minus negative 1/3 is plus 1/3. We get the natural log of 17 minus the natural log of 5. And like you could leave this if you wanted to. I chose to kind of simplify it a little bit. We get 64 over 5, and then 1/3 division between logs becomes, subtraction between logs becomes division within the log. So natural log of 17 minus the natural log of 5 becomes natural log of 17 over 5. All right, that's the entire problem set. I hope you found this helpful, and good luck.